Hello class. So for this session, we will discuss the set theory. Now, what is a set? A set is a well-defined collection of objects that consist of unique objects or elements. So the elements of the set can be numbers, letters, or others such as planet or items. Now, these elements are listed inside the brackets. Now, the sets can have finite or infinite number of elements, or they can be empty. And these empty sets are called null set, which have no elements and is denoted by the symbol, is denoted by this symbol. Okay? Now, we have the examples here. For set A, it is a set of single-digit positive numbers. So we have A is equal to 1, 2, 3, 4, 5, 6, 7, 8, and 9. Another example is a set B, which is the set of primary colors. So we'll have B is just equal to the set of red, yellow, and blue. And the last one, we have C, is a set of numbers between 0 and 5. Now, we will proceed to describing ways of describing sets. We actually have two ways to describe it. First, a set may be described by a roster method or tabulation method. This roster method is used by listing the elements, and the second one is the set builder notation or the rule method, which is by giving specific rule for determining whether the object belongs to the set. Okay, now let's have examples. So the first one is A is set of vowels in the English alphabet. Now we will try to use the two methods to describe this sentence. The first one is the roster method. So roster method is just by listing the elements. So we have A is just a set A, E, I, O, and U. Next, for the rule method or the set builder notation, we have A is just equal to X, such that X is the vowel in the English alphabet. Another example, the set of distinct letters in the word mathematics. Now take note of the word distinct, okay? So we have roster method. We just have M, A, T, H, E, I, C, and S. The rest of the letters, they are already in the set. We can only have a unique element. We must have a unique element in the set. So though we have two M's in mathematics, we can only write one. Okay. Next, we have the rule method. We have Y, such that Y is the distinct letters in the word mathematics. Now, can you see the difference in them? Okay. Now, I have a question. What is the set of possible outcomes from rolling a die? So, we have here, it's possible that you have 1, 2, 3, 4, 5, or 6 dots, correct? Now, what are the set of possible outcomes? So for even, we have 2, 4, and 6. Now, the largest set possible is called the universal set. Now, in our example above, ito siya. Ito. This is our largest set, which is A. If we are just talking about the die here. So A, we have 1, 2, 3, 4, 5, 6, and we have A sub E, we have 2, 4, 6. Now, since this A sub E comes from the possible outcomes, pero meron lang siyang restriction, the even outcomes, we call that the subset. Okay? Now, A sub E is a subset of all possible outcomes of A because it contains some of the elements of A. Now, take note that the null set is also a subset of every set. Okay? So, in other words, whenever you have a set class, tapos, uh, you have a universal set and you are given another set such that all the elements of the second set are coming from the first set. The second set is called the subset. Now, this is the notation. Ito siya, yung notation or the symbol of subsets. And we have A sub E is a subset of A. Now, we will proceed to the complement set. So, the complement of a set is the set of all the elements in the universal set, but not in the set of interest. Okay. Now, we use this symbol, or sometimes we use letter C. What is the complement of a set of even outcomes when rolling a die? So remember, in our universal set, we have this. A is 1, 2, 3, 4, 5, 6. And the set of even outcomes, we have A sub E a while ago. We have 2, 4, 6. So the complement of the set that is not in the set of even numbers is just the set 1, 3, and 5. Okay? So we cannot use all the numbers. We'll just base our answers to the universal set. Okay. Next, we have the set difference. Now, the set difference class is the set of, we have two sets A and B, in which we have A, which is not in B. Now, we have A minus B in notation, and we read it as X such that X is in A and X is not in B. Sometimes it is also written as this. Okay? Now we have this example. So whenever we have A, this is the shaded green one is A minus B, or just like this one. Okay, so we have B. B minus A means we get all the common elements. So itong nasa gitna, this is the intersection. This is the common elements of A and B. So basically, hindi sila kasali sa final answer. Now let's have the examples. Okay, so we have set A and B. For set A, we have 1, 2, 3, 4, and B is 1, 4, 5. So the difference of A minus B is just 2, 3, since si 2, 3 lang yung wala sa set B. All other elements in B, such yung 5 yung nandyan, will be disregarded. Okay? Now we have set C and D, where C is XYZ and D naman WXY. Now if you notice, common si X and Y, so we remove them. So we are left with this element Z. The last one, we have E and F, with E for 1, 2, 4 and F 1, 2, 3, 4, 5. Now, the difference of E and F will be empty. Next, let's have the union. Now, the union of two or more sets contains all the elements in all the set. Okay? So the union of both sets A and B are the elements in either A or B, or we have both. It is denoted by this symbol. Okay? Now, we have a question here. What is the union of set A? The outcomes of rolling a dice, and set B, all positive integers between 7 and 11. Okay. So our set A, the possibility of rolling a die, we have 1, 2, 3, 4, 5, 6. And the set B, which is the positive number, integers between 7 and 11. So we have 7, 8, 9, 10, 11. Now, to get the union, we will just combine the elements of set A and B. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. If ever may mga cases na mag-overlap, you just list one if merong common. Okay? Next, we have the intersection. So the intersection of two or more sets contains all the elements that are in the set. For example, okay, the intersection class of two or more sets contains all the elements that is common. Sorry. Dapat common siya in the set. Okay? And we have all the elements in set A and B. That means common siya. We use this symbol for the intersection. Now, question. What is the intersection of set A, the outcomes of rolling a die, and B, all positive integers between and inclusive of 4 and 9? So if we can see here, the set A is just the numbers from 1 to 6, and the set B is from the numbers from 4 to 9. Now listing, the only common ones are 4, 5, 6. So that set 4, 5, 6 is our intersection. Okay? Next, we have the disjoint sets. The disjoint sets are two or more sets that have no elements in common. Therefore, their intersection is empty. For example, the set of all 3D shapes with curved surfaces, and B, the set of polyhedrons are disjoint sets since wala namang common. Now, the intersection of disjoint sets is this empty set. Okay? Okay. Now we have the Venn diagrams. Okay? So, this is an example of the Venn diagram. So, I have showed this similar example to you before. So, this is just seen through using the word this drawing. So, we have this box and the this one. This is the universal set. So, lahat ng elements na wala sa A and B, pero nandiyan sa universal set, will be put here. So, outside the circles. And this is set A and B there. And the set A class, if they and B, if they have intersection, dito nyo ilagay sa gitna. Okay? So, dito yan siya. So, whenever we have A, so ito lang siya. For A complement, ito. For A union B, silang lahat from A and B. And A union B complement, so it should be outside the set. Whenever that we have B, the B complement is just this. And A intersection, the common in A and B. And A intersection B complement, is this set? Yung naka-green, violet, and what's this? Is that orange? Okay. Yan sila. Okay?